Good morning. I am Donna Young, the National Event Supervisor for the Science Olympiad Astronomy event. And we are here today because I am going to present to you the event for 2012 in Orlando this next coming May. And this presentation is not meant to teach you the content. This is to give you an overview of the content and help give you suggestions as to how best to prepare for the event and what the best resources are to prepare for the event. Okay? So if you are familiar with the astronomy event and you have participated in it in the past, the last couple of years has been galaxies, and as you know, we rotate the content every 2 or 3 years. So this year, I've done something different. In an attempt to give you a much less amount of material to have to prepare for, I have limited. We're going back to stellar evolution, but it's stellar evolution focusing on type 1a supernova events. So this is going to eliminate a whole amount of content, whereas in the past, the stellar evolution events covered the entire stellar evolution for all mass stars. But now we're going to concentrate on solar mass stars in the solar mass range. So, stellar evolution in type 1a supernova. You will see this in your event description. You're very familiar with this. It tells you what the content is going to be. You know that there are a team of 2 preparing for this, and you really do need a team of 2 for this particular event. And you have, it's a 60-minute event, but 50 to 55 minutes depending, or 58 minutes depending upon how much time it takes us to get started and to finish up at the end of the event. Normally we have about 55 to 57 minutes for the actual competition. And there seems to be a lot of confusion, even though I think it's quite clearly stated here as to what resources the team members are allowed to bring to the competition. You are allowed to bring, each team member is permitted to bring either a laptop computer or a 3-ring binder. And the reason for this is I wanted to eliminate people bringing boxes or stacks of textbooks to the competition, because a textbook will not help you whatsoever. Neither will connecting to the internet. That's not my rule. That's a general Science Olympiad all-event thing where no internet access is allowed, because there are some events where you probably could find some of the answers on the internet. If you're familiar with my competition, there is no way accessing the internet will help you with this event. It won't help you any more than a textbook will. So you've got, 50 to 55 minutes to answer anywhere from 60 to 85 questions, of which many are 2- and 3-step process types of questions. And when it says 3-ring binder, it doesn't matter what size binder. However, the biggest you can get. And when we get further along in this presentation, I will tell you pretty much what you should put in that binder. Now, there's been a lot of controversy because I allow laptop computers in my competition. I still have a lot of controversy of people thinking that's an unfair advantage for students who don't have laptops. So I will tell you, though, that most of the top winners in my event who place in the top 6 at national competition have 3-ring binders and not laptop computers. So it depends upon how you use the resource. So I would assume that you're using that laptop as a 3-ring binder in electronic form only. I'm going to keep talking about, as we go along, the coach's manual that I wrote for the Science Olympiad. They have it for sale on their store online for $16, and that is the best resource that you can possibly get to prepare for this event. Okay. The usual. Stellar evolution and everything that has to do with the different stages of stellar evolution that lead to type 1a supernova events. You know, stellar properties and motions. And the important thing right here to look at are the deep sky objects, because all of the questions are focused on the deep sky objects that I've selected for next year's competition. So I have categorized them here for you. Stellar nurseries, of course. We have two deep sky objects representing stellar nurseries, the Rosette Nebula and the Carina Nebula. We have one representation for the protostar stage of stellar evolution, the T Tauri, that is specific to the solar mass category stars only. And then we have some red giants, because that's also a stage of evolution in order to get to the type 1a supernova event. I have some examples of red giants here, Myra and BP Piscium. And then I have our Lyrae and globular clusters, which might seem an odd place to categorize it with red giants, but as we go along, I'll explain to you that association among those. We have planetary nebulae and white dwarfs, several of those. Sirius B, Myra, which is a red giant, also has a white dwarf companion. CH Sig Euscorpii, this binary white dwarf system with a really sexy name of RXJ0806.3. And NGC 2440, the token planetary nebula for this particular event. And we have 4 different type 1a supernovas. Stellar evolution begins with star formation, and star formation takes place in very large, cold molecular cloud complexes. They're extraordinarily beautiful. There have been tons of images taken of stellar nurseries. The ones here of the Carina Nebula were taken by Hubble. In here, you can see that there are these areas, these dark areas that have been carved out from the gas and dust. Those have been carved out by stars that are forming within this cloud. Anytime you get within a cloud, anything happens that you have a little bit of gas and dust, it's a little bit clumpier, then gravity will start to have its way. And it will start to attract more gas and dust. So the more gas and dust it attracts, the more massive it becomes, the more compact it becomes, the more layers of material that stop heat from leaving the cloud of gas and dust, and it starts to get hot inside the little clump. Okay, so, and it keeps just accreting and building.